So a while back, my team and I were running into a problem. We had a few singletons in our project and we were referencing them as we needed to. However, as the project grew, so did our need for singletons, singleton managers, and our abuse of them. Eventually, without meaning to, we had spaghetti code. Circular references, systems talking to each other in ways they shouldn't, managers depending on managers. It really got out of hand. So we needed a way to clean all of this up. So we asked, what if we could centralize all this? Create a system where dependencies are registered once and injected wherever needed, without tight coupling. That's how we started building our Service Locator, the Geo dependency resolver. I want to show you a simple example of what a basic Service Locator might look like. It's lightweight, simple, and it's built around 3 core ideas: registering dependencies, choosing between singletons or transients, and resolving those dependencies from anywhere in the project. For those that might not be aware, a singleton is an object that lasts for the entire time that the project is running, whereas a transient only lasts temporarily. You don't need it forever, you just need it for a moment. Here's an example of a really simple service locator. At the top we got 2 dictionaries, one for singletons and one for transients. When we register a service, we choose whether it should leave as a singleton, meaning it'll always exist once it's created, or as a transient, where a fresh instance is made every single time it's requested. The separation helps us quickly check, does the object already exist, or do we need to build a new one? Now, down here, we've got the resolve method. This is where everything gets tied together. We pass it the type we're trying to resolve, and it first checks the singleton dictionary. If the object already exists, we return it. If not, we move on and check the factory dictionary. If we registered it as a transient, the factory will return a new instance on the spot, and just in case we forgot to register the object altogether, we throw an error. That way, we immediately know something's missing instead of silently failing. Now I want to show you a quick example of how it actually looks like in an actual running project. So here I am inside my Unity scene. You can see that I have the main menu scene open and I have an object called preload. I turned this into a prefab because it was easier for me to move it around. Inside this preload prefab, I have a component called preload resolver. Preload resolver's job is to register the singletons that are inside of here so that I can then reference them via my dependency register everywhere else. Short answer is, its job is to just register all these, so I can call them everywhere. If we take a quick look, you can see that I have this dependency object, which can be seen in the component here on the right, and it's being used everywhere in order to just get the references that I need. For example, dependency object get component I faction manager. You can see the faction manager here on the right. I have the faction manager reference, and on line 57, you can see that I'm adding it as a registered singleton inside the dependency register. Now, how is it used? So if I go into one of my other scripts, waypoint group handler, you can see when the object gets awakened, I can then just call get service, and then I can get whatever I need. So as long as these are called inside of the preload resolver, I could then use them anywhere that I need to inside of my script later on. Now, the fact that it's also inside of the main menu scene means that I'm registering all these things before they are even used inside the game. So now that they're used, I convert the object into don't destroy on load, which is right here. And once this object is converted, then this object will always exist as long as the game is running. Now, before we finish this off, I want to share with you a few quick warnings before we wrap this up. Now, first off, avoid calling resolve inside the update loop or other tight loops, especially with transients. It can get pretty expensive the more you use it. Secondly, make sure all your services are registered before they are used. Otherwise, you can run into some pretty unique scenarios and some pretty unique errors. And then finally, keep all your registrations in one place, like a bootstrap scene or initializer, just like we did with the preload in the live example scene. Building the system taught me a lot, not just about dependency management, but about architecture in general. And I want to share with you a couple takeaways. One is, it forced a consistent style. So regardless who was inside the project, it was very easy for them just to hop on board and start working with it. It was easy to understand. You don't really have to know how it works under the hood to know how to make a registration and how to get a service. You're also in full control, which means that if you don't like how it works, it's very easy to change and manipulate in any which way that you want. And it actually scales very well. For small to medium-sized projects, it's worked in many occasions. Now, some of the cons that I want to share is that it really lacked a lot of flexibility out of the box. So as you can see, it was a very simple system. So there's still like more we could do with it. There is no auto resolution or reflection, so everything has to be registered manually. That can become tedious if you have a lot of services. And if your team grows, you're probably gonna add a couple safeguards, like double registration, checks, or interface validations. If this video saved you from a future spaghetti code disaster, go ahead and give it a like. And if you're into clean architecture, custom tools, and making your code less terrifying to look at, hit that subscribe button. I've got more coming soon, and trust me, you won't want to miss it. Alright, go write some beautiful code, and I'll see you on the next one.